morning, grade 11s. Carrying on with the eye, and we are getting onto defects of the eye. Which at your age, you are probably around the age where you start to realize that you're short-sighted, mostly that you're short-sighted, because this is when short-sightedness, for the majority of the individuals who end up being short-sighted, this is when it actually starts to take effect. Okay, but we'll talk about a few different eye defects. Okay. For interest, but not to learn. A healthy macula, and remember that that is the region around the fovea centralis and the retina, with the highest concentration other than the fovea of cones. So a healthy macula ordinarily is capable of achieving at least 20/20, which is considered normal vision, even if this is with the correction of glasses or contact lenses. You don't have to learn this, but you might want to know what 20/20 means, 20/20 in an eye test. And so in the United States, the standard placement of the eye chart is on a wall that is 20 feet, hence the 20, in obviously metric terms, 6.096 meters away from the eyes. Now, you know that the majority of eye doctors' offices don't have rooms that are 20 feet long, so what they do in a smaller room is they use mirrors to make it appear in front of the patient at a simulated distance of 6.96 meters. But it's actually been passed backwards and forwards and backwards and forwards at the mirrors. So 20/20 visual acuity is considered normal vision, meaning the patient can read at 20 feet a letter that most human beings should be able to read at 20 feet. And eye charts can be figured in various ways, configured in various ways, but generally, if during an eye test, a patient can read the big E at the top, but none of the letters lower than that, then the vision is considered to be 20/200. That means that the patient can read at 20 feet a letter that people with normal vision can normally read at 200 feet. So at 20/200, visual acuity is very poor. Usually the 20/20 line of letters is fourth from the bottom. So in that eye chart next on the right there, it would be line 8. Okay. With 20/15 or 20/10 or 20/5 below that. Not many people have 20/10 or better visual acuity, but many animals do, especially birds of prey, which are estimated to have a visual acuity of 20/5 or even better. Okay, so that was just an explanation of what 20/20 means. Right, so the first eye defect, and this is the one I think that most people who have problems with their eyes at your age, this is generally a problem. Okay, so it's called myopia, and commonly it's known as nearsightedness. And there are two reasons for this. Either the eyeball is too long, or the lens is too biconvex and can't get less biconvex enough, or a combination of both of them. The issue is that if you look at the refracted light rays, the focused image or focal point falls in front of the retina. So it's at this point where the image is focused. The light rays do reach the back of the eyeball, but by then they're totally out of focus. Now that would be exactly the same as taking one of our data projectors, which has been carefully set up to be in focus on the board, and it has been placed at that particular distance. But if you took one of those data projectors and you moved it backwards away from the board, then the image would no longer be focused. Okay, so the focused image Yeah. Get rid of it. Okay. So the focused image is in front of the retina. Okay. And so obviously what has to be done in terms of correction of myopia is because the eye lens, or yeah, it's basically the lens, refracts the light too much and the focused image falls in front of the retina. What happens is the lens that is put into a pair of glasses or a pair of spectacles is a diverging lens. So it has an inner surface that is concave. And what that does is it diverges the rays of the light before they enter the eye. So because the rays are diverged before they enter the eye, it doesn't matter that they are refracted too much, because the image that falls on the retina will be a focused image. Okay, so a diverging lens would correct myopia. For interest, an option is lasik, which is laser surgery of the eye. So what the laser surgery does is it removes, it flattens the cornea a little bit. Okay, so instead of the cornea, if you look at this diagram on the right, being so bulging or so convex, the laser surgery shaves off a piece of the cornea, and so the cornea becomes flattened. And because the cornea is flattened, the light rays are not refracted by the cornea as much as they would be by a normal cornea, and that would help to correct the problem. Now, just warning you up front, if you go and get laser surgery done on your eyes, first of all, you've got to be a lot older to have it done. The eyes have to have stabilized. And you'll find that if you've got myopia, it'll probably carry on getting worse and worse and worse for a number of years, so into your 20s. Now, I know that I was still getting stronger and stronger glasses for a number of years after the figure that I was originally told the eyes would stabilize at. But the optician will tell you this, and the eyes have to be stabilized. Make sure that you find an eye surgeon who is of a good reputation, so somebody who's guaranteed that your eyes are going to be fixed if you have this particular kind of laser surgery, because if it messes up, you're messed. I had mine done, and it has been absolutely amazing. Okay, if you go to this particular video site, there are a number of videos on how various conditions affect vision. And I'll try and record a lesson where I actually show you those particular things. But anyway, we'll try that. Hyperopia. In hyperopia, one of two things could happen. Either the lens is not biconvex enough, or the eyeball is too short, or both of those. And this is commonly known as farsightedness. And here what happens is the point of focus falls behind the retina. Okay, now obviously it can't fall behind the retina because the eyeball stops it. But this is where the focal point would be. And so by the time those light rays reach the retina, they are not yet focused because they're not refracted enough by this quite flat lens, or the fact that the eyeball is too short. Quite obviously, the correction would be giving a lens which does some converging before the image before the light rays enter the eye. This is not a good picture. I don't know why I used this one. It looked good at the time. But it also shows the inner surface being very concave, like for short-sightedness. So just go with a lens that is, I will replace this, go with a lens which is more biconvex. And that then will make sure that it refracts the light rays inwards, not diverging, converging the light rays before they enter the eye, so that a focused image falls on the retina. Okay. Now what I want you to do is go back to, I think this was in lesson 4, and watch the remainder of this YouTube video. Right. Let's talk about something called presbyopia. Now, this usually begins affecting vision around the person of age 40, and by age 50, almost everybody has presbyopia. Now, you might already have noticed this in your parents, but you probably will have noticed it in your grandparents, where if they are trying to read, they have to hold something quite far away from their face to be able to read. And the reason why is the natural crystalline lens of the eye loses its ability to change shape and to do accommodation, meaning its ability to switch from seeing objects at a distance, which remember is the norm. That's what the eyes can do under normal circumstances. But because the crystalline lens is no longer as elastic, it's not easy to then see objects close by. So the lens can't become biconvex enough. So a result of being presbyopic is having to hold things further away to read, or to have to use reading glasses or bifocals or multifocal glasses. Okay, so normal vision would be as is on the left-hand side, and an aging eye, the lens loses its flexibility with age, and the focused image or focal point is behind the retina, and therefore to correct this requires a lens that is biconvex. So you will see that reading glasses tend to have a very convex outer surface to help refract the light rays convergently before they actually enter the eye. So to form a focal image, focused image, focal point on the back of the eye. What multifocals do is they have if you look down the lens of the glasses, they become thicker towards the bottom of the glasses than they are at the top. So a person who wears bifocals or multifocals looks up through the top of the lens to see distance objects in focus, but would look down through the bottom of the lens to see things that are close by. And in a multifocal, there are varying degrees of thickness of the lens going down like that. So far intermediate, looked at there. Intermediate, looked at there. Close by, looked at therewards. Most biconvex. And some people struggle to adapt to this, finding it quite difficult and making them feel that they are seasick. Okay, now this is really, really interesting. Well, for me it's very interesting. Is contact lenses for presbyopia. And so what actually happens is there are concentric rings of differing thickness of the contact lens, where the blue rings are light rays for far vision, and the yellow ones are light rays for close vision. Now, this sounds really, really weird, but the brain is able to tell the difference. And so the occipital lobe of the brain, that region, the optic center, would, I'm going to say focus on, but that doesn't sound correct in this particular thing, would concentrate on, if a person was looking at far objects, then the optic center of the brain would concentrate on the light rays which come from this ring, that ring, and that ring. But when looking at close by objects, would concentrate on the light rays which come through this ring and this ring. And I know that it sounds really, really weird, and it sounds as if it's not possible, but it definitely is possible. So some of you might know of contact lenses or glasses for monocular vision. And this is what my contact lenses used to be like when I first started presbyopia. So I was very, very short-sighted until my laser surgery, but I just used to wear either glasses or contact lenses. And then when I started getting presbyopia, I was devastated, because now I was living in Durban and it's really, really hot, and wearing glasses is a complete nightmare because they just run down your nose, because one sweats copiously in Durban because it is so incredibly hot. So I was terribly upset about the fact that I was going to have to start wearing reading glasses. And the optician said, no, hold on. He had just read a journal article in the scientific journal about a new way of dealing with presbyopia. And he said, let's try and see. So I was, in fact, the first person in South Africa on whom this system was tried. So what he did was he put into my right eye a contact lens for seeing close by. And into my left eye, I had a contact lens for seeing far away. That sounds really, really strange. And it worked in exactly the same way as this kind of contact lens works. This one in front of you in the picture, the light rays for close and the light rays for far. And what actually happens is that the brain processes the two images differently. So if I was looking at something close by, the brain would concentrate on the light rays coming through my right eye. And I would be able to read close by objects, and it was absolutely fine. And if I looked at distant things, then it was the light rays from my left eye coming through the distance contact lenses. Now, it seems really, really strange, and certain people can't adapt to the system. So it's called monovision. It worked extremely well for me, to the extent that when the eye specialist lasered my eyes, I thought he was going to laser them both exactly the same, and that I would have to wear glasses either for seeing far or for seeing close. And the eye specialist said to me, no, monovision in your contact lenses has worked so well for you, why don't you just laser your eyes in monovision? And so my right eye is lasered for seeing close, and my left eye is lasered for seeing far. And up until a year ago, it worked perfectly for me. And it was only about a year ago that, because I work so much on the computer and do so much close work, that my optician said to me, no, I need to perhaps start wearing reading glasses to prevent eye strain. So now I do wear reading glasses, but when I'm not looking down at the computer or reading or marking, I don't have to wear glasses at all. And so it's just interesting that the brain is able to differentiate between these two different kinds of light rays. Okay, astigmatism. So what astigmatism is, and many of you, when you get your eyes tested, will be told that you have astigmatism. So this is when either the cornea or the lens that mostly it's the cornea is irregularly shaped. And it causes light rays to focus at different points, and the result is blurry vision both at near and distant vision. So what I want you to look at is look at the curvature of, oh, I don't know what's just complete there. The curvature here of an orange versus the curvature of this egg. Now, both from top to bottom in the orange and from left to right in the orange, the curvature is exactly the same. Okay, but if you consider an egg or a rugby ball, then the curvature from top to bottom in the egg is greater than the curvature from left to right. Okay, curvature from here to here, because of the shorter distance from top to bottom in the egg here, is greater than from here to here. So instead of having a perfectly spherical curve to the cornea is irregularly curved. And what that does is it makes the light rays bend differently depending on the angle at which they hit the eye. Okay, so now this is the astigmatism test. Many of you will recognize something like this when you go to the optician, and the optician says which lines are lighter, which lines are clearer, darker, on the red or the green, and that's this kind of test. And that is a test for astigmatism. Okay, all right, so we're going to leave it at that for today. I will, in one of the lessons coming up, go through the video on certain eye defects, but I want to finish them all before I do that. Right.